Today we're going to look at section 5.4, which is the sum and difference formulas for sine, cosine, and tangent. So let's first start off by looking at these two statements here. It says, is sine of 90 minus 30 the same as sine of 90 minus sine of 30? So people look at this and they think, yeah, sure, just distribute your sine just like you normally would. Sine times 90 is sine times 30, so it'd be sine of 90 minus sine of 30. But let's take a little bit deeper look into this and figure it out. Sine of 90 minus 30 is really just the same thing as sine of 60 degrees. Okay? Well, sine of 60 degrees, if you look at your unit circle, or if you look at a 30, 60, 90 triangle, I'm going to look at the 30, 60, 90 triangle real quick. We have 1, 2, square root of 3. So sine of 60 is root 3 over 2. Okay? So let's see if that's the same thing as sine of 90 minus the sine of 30. So sine of 90, if you're looking at your unit circle, 90 degrees is right here, and that is the point 0, 1. Sine is the y value, so sine of 90 is 1. Minus sine of 30 degrees. Sine of 30 degrees, if you look at this 30, 60, 90 triangle here, sine of 30 is 1 over 2. So we have 1 minus 1/2 is 1/2. So the question is are these two things equal to each other? Is root 3 over 2 the same as 1/2? And the answer is no. You cannot take the sign and just distribute it like you would normally would in a algebra equation. Okay? So these two things are not alike at all. Let's go ahead and look at it for cosine. Let's see if it's the same thing or if different rules apply for sine and cosine. So cosine of 30 plus 120 is just really the same thing as cosine of 150 degrees. Cosine of 150 degrees, if you think about the unit circle, cosine of 150 would be right about here, and that would be in the 30-degree angle, and that would be 1, 2, square root of 3, and that's negative, so cosine is adjacent over hypotenuse, which is a negative root 3 over 2. Now let's look at it for the cosine of 30 and cosine of 120. Cosine of 30, if you look back up here, cosine would be root 3 over 2. Cosine of 120. If I look at a unit circle again, because I like to look at that, that would be a 60-degree reference angle. And this would be 1, 2, square root of 3, and negative 1 in there. Cosine of that would be a negative 1/2. If I simplify those two things together, get the common denominator of 2, that would be square root of 3 minus 1. And again, we look at to see, is this the same as this? And of course the answer is not again. So we cannot look at those as just distributing the cosine and the sine to those. So what we have is the sum and difference formulas. Okay? Now, these appear to be long and complicated. The sine and cosines aren't as bad as the tangent ones, but after you get some practice with them, it all makes sense. What happens here is if you take cosine of alpha plus beta, you break that up into the cosine of alpha, cosine of beta, minus sine alpha, sine beta. Okay? I'm not going to read over all those because you can do that. But simply taking them and plugging in the different values, and what you want to do is, for example, if I had something like the cosine of 75 degrees, okay? I don't know what cosine of 75 is, but I do know that that is 30 plus 45, right? So what I would do is I would take this formula right here, this alpha plus beta, and plug in the 30 for all the alphas, and plug in the 45 for the betas, and figure out what it is based on 30 and 45, which I do know from my unit circle, and be able to figure what the cosine of 75 is, and not try to use the calculator and get a decimal answer. So now let's look at example number 1, which is the sine of 75 degrees. Okay? So again, we don't know what the sine of 75 is just by looking at our unit circle, but we can do sine of 30 plus 45, right? So if we follow the formula for the sine, and I'm just going to write it here so I have it handy here, the sine of alpha plus beta is the same thing as sine of alpha cosine beta plus cosine alpha sine beta. Okay, so I'm going to follow that rule and apply it to this. This right here, the 30 is my alpha, and the beta is my 45. So I'm just going to take it and fill it in. Sine of 30 cosine of 45 plus cosine of 30 times sine of 45. So now what you go do is just go through and fill in everything. If you know your unit circle, this is not a problem. If you don't, you can draw out your triangles and figure it out. I do know that sine of 30 degrees is 1/2. Cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. And then sine of 45 degrees is root 2 over 2. So now we've plugged in all the values that we know for these simple angles here. Now we just got to go through and simplify this out. So just multiply. So that would be root 2 over 4. And this would go to root 6 over 4. We want to add those together. Thankfully, we already do have a common denominator. That common denominator is 4. And then we just add the numerators together because we didn't change up anything. So that is the square root of 2 plus the square root of 6. And there's your example number 1. So let's go ahead and go to example number 2 now. Cosine of 11 pi over 12. The first thing I always do when I come to things like this is I do not think in terms of radians more than degrees. So I'm going to show you how to do it in terms of radians and also degrees. So I'm going to first change that 11 pi over 12. I'm going to change it to degrees because I see it a lot easier that way. So that would give me, 165 degrees. Okay? So, what I do is, and if you did this in fraction form or the radian form, 11 twelfths would work also. But what I do is I do cosine of 165 degrees. Okay? Now we've got to think about that is really cosine of watt plus watt or watt minus watt to get to 165. A lot of different things are possible with that, but I go, the first thing I think of is 45 degrees and 120 degrees. Okay? And if you're wanting to do it in radians, that would be the same thing as the cosine. Let's see, 45 degrees is 1/4 of a pi, and 120 degrees is 2/3 pi. Okay? So if I take the 11 twelfths, if I do 1/4 of a pi plus 2/3 of a pi, that would give me to 11 twelfths pi. Okay? Again, I think that's a whole lot messier, so I'm going to focus more over here. But if you look in the example that we worked out in the iBook, you will see that it also shows it worked out in terms of radians. So I have this here. And then if I follow the formula for the sum of cosine, that would give me the cosine of 45 degrees times cosine of 120 degrees. And that's a plus, so it's going to be minus here. Sine of 45 times sine of 120. Okay? So, cosine of 45 degrees is the square root of 2 over 2. Cosine of 120 degrees is a negative 1/2. The sine of 45 degrees is root 2 over 2. And then the sine of 120 degrees would be root 3 over 2. So let's simplify that. That'd be what? Positive negative is negative. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. Minus, again, denominator is 4. Square root of 2 times square root of 3 is the square root of 6. So that, thankfully, we still have a common denominator. Don't change it up at all. And we have a negative root 2. Negative root 2 minus square root of 6. Okay? And that would be the exact answer for the cosine of 11 pi over 12, instead of plugging it into a calculator and getting a decimal answer. Now example number 3 looks a little bit different. It gives us, if we compare this expression here to the tangent rules for the sum and difference, you can see that it matches up with one of those, where alpha is going to be the 141 and beta is going to be the 81. So it looks really complicated, and I would not even want to try to come close to figuring all that out. But it makes it a lot easier if we follow the rule that they give us of the tangent of theta, and if, when there's a minus up on top, it follows that follows the rule of tangent of alpha minus beta. Okay, and again, our alpha is 141 because it's there and there, and our beta is 81 because it's in both places there. So it does follow that pattern if we compare those to the rule. So what we're doing there is finding the tangent of 141 degrees minus 81 degrees, which is really just the tangent of 60 degrees. And if I draw out my quick little triangle there, start that over again, draw my quick little triangle, if I don't have it memorized, 30, 60, 90, 1, 2, square root of 3. Tangent of 60 would be root 3 over 1, or just square root of 3. And all this big mess goes simply just to the square root of 3. The last example for this note says if alpha is in quadrant 2 and beta is in quadrant 4 and sine of alpha is 4/5 and tangent of beta is negative 12/5, find the exact value of cosine of alpha minus beta. So the first thing I'm going to do, I'm going to write down the rule that goes for the difference of cosines. So that'd be cosine of alpha, cosine of beta, plus sine alpha, sine beta. Okay. So I know I've given the sine of alpha, so I'll just be able to plug that right in. But then I don't know what the cosine of alpha or the sine and cosine of beta is. So what I always do with every single one of these is I draw a little picture first. Okay? And it says alpha is in quadrant 2, so I know alpha is going to come up here. So this is alpha. And it says sine of alpha, which is opposite over hypotenuse, is 4 over 5. So again, use Pythagorean theorem or your Pythagorean triples, and you know that this side will be 3 and it's going backwards, so it's a negative. Okay. Do the same thing for beta, which is in quadrant, tells us that beta is in quadrant 4. Okay, so this is beta here. It says tangent, which is opposite over adjacent, is a negative 12/5. So tangent, or the 12 is a negative and the 5 is positive. You have your 5, 12, 13 triangle. Pythagorean triple there. Okay, so now I can plug everything back into the nice formula that we have and be able to figure it out. So we gotta first figure out what cosine of alpha is. Cosine is a negative 3/5. Cosine of beta, come down here. Cosine is 5/13. Plus sine of alpha, sine would be 4/5. And sine of beta, come down here, will be a negative 12 over 13. Okay, and we got all those values by just simply drawing our two triangles out and plugging those things in. Okay, and so now what we're going to do is simplify our numbers there. Here, these cancel out to 1s. Those reduce to 1s, so that goes just to negative 3/13. Plus, well actually it'd be a plus times a minus, so that really just goes to a minus. Erase that there. Nothing, unfortunately nothing reduces there, so that'd be what, a negative 48 over, was it 65? Okay. If I'd have kept that in terms of 65ths, I'd have been able to reduce that fraction a little bit easier, but that is okay. If I go through and I can do it on my calculator or whatnot, I'm punching it in my calculator right now, negative 3/13 minus 48/65, and change it back to a fraction, that'll give me a negative 63/65. Okay? And that's the exact answer. If you want to see me work that out in this fraction form real quick, if you do not reduce those out, that would just be negative 15/65 minus 48/65. And then since you have your common denominator, should have done it this way the first time, but easier than punching the calculator. And then negative 15 minus 48 gives you the negative 63. Okay? So either way, calculator or no calculator, gives you the same thing. But I was able to find the cosine of alpha minus beta given the sine of alpha and the tangent of beta, and still get the exact value for that answer.